Welcome. My name is Jose Posada. I'm a senior clinical data science working for the Stanford Center for Biomedical Informatics Research and Research IT at Stanford Healthcare. In this video, we're going to cover tutorial 4, part 3 of Stanford Medicine Tools for Healthcare Data Science, and in particular, we're going to cover the node table. This node table is part of our STARR-OMOP dataset and is part of the CDM convention. This node table has several characteristics that makes it very useful to enhance cohorts from all the other structured patient data. This node table will have all the metadata associated with the provider, with the visit, and with the person which this node was written about. In particular, we will also have all these fields to our disposal, noting that we have the node date time that to our best approximation will be the time where the node was written. Also, very important to notice that in the node source value, we are populating a scrambled version of the primary key for that particular node in Epic Clarity. If you want to know more about the conventions of the node table, please go to the link in this link below so you can actually see all the conventions associated with the node table. Now let's jump into how to use this node table from Niro. In the past tutorial, I show how to get to this point where you have a Jupyter notebook that is open. For the purpose of the recording, I already run all the cells in this notebook, so we can really go and follow along this. First, what you need to know for this notebook and for all the notebooks is that the Niro project is your own Niro GCP project. In this case, for me, it's some Niro PHI read. Then your user ID is your user ID in the Niro on-premises platform. Usually it's your SUNET ID. Then in the prior tutorial, we actually generated an application default credentials file that is no more than the file that helps us authenticate in Google Cloud. Then we are creating a client. This client is a BigQuery client that ensures the connection to BigQuery. And you can see that the project we are passing to this client creation is your own Niro project, because from your Niro project is that we are going to connect. From there, as explained before, you can easily access the datasets in other projects. That includes the RIT managed GCP projects. Then we specify some parameters that are common to all the queries that we're going to make below. First, the CDM project ID is the project where this data lives, is in RIT PHI STAR-PROD. Then we're going to query the latest de-identified dataset that we have made available at Research IT. Then this work project ID is a project that you will need write permissions to be able to work. That is the reason we call it work project ID. You don't have write permissions in the RIT projects. You only have write permissions in your own GCP project. And then here is just a name. In this case, is just my SUNET ID-explore. That is the data set where all these intermediate results can be saved. Feel free to change this name. And then in case you have not created already a data set to work on BigQuery, then this line of code will help you create a data set. Then we have a convenience function that to print node text or clinical node text in these Jupyter notebooks. Why is that? Because the clinical notes we receive from Epic Clarity are a strip of new lines and all sort of special characters, including all HTML special characters that may be contained in the clinical note. So this small auxiliary function will help you at least make it slightly more readable in case you want to do it. However, for the purpose of this recording, I'm not going to show any clinical text here because, as we mentioned before, this is high risk data. So we are not going to show it here, but you have access to this notebook and you can easily run those small cells that I'm not going to run in this tutorial on the Nito Secure Compute platform. Then let's check how this table looks like. So we are querying the table, and then we immediately see that we have all the available columns here. First, the node ID. The node ID is the primary identifier, or is the unique identifier for each one of the clinical nodes. It is important to note that that identifier is not constant whenever we generate a new dataset, so it will always change. However, the next identifier, person ID, will not change. This identifier remains stable between each one of the runs. So this is the patients whose this node is written is about. Then the node date time is our best estimation of when this clinical node was written. Then node type concept ID and node class concept ID is our best estimation of what is the classification category of this particular clinical node. Then we have node title, that is pretty much a copy and paste of whatever we find in the source for you to check and to have provenance of the data. Encoding concept ID relates to the encoding of the string. We are not populating, this is just all concept ID zeros. Then we have language concept ID, that is pretty much just one concept ID that is English. Then we have link to two other tables in the CDM. First, the provider table. We have the provider ID column, which links each one of these nodes to one of the providers in the provider table. Then we have the visit occurrence ID that links this particular node with a visit in the visit occurrence table. We have already populated the visit detail ID, but we have decided not to populate this column. If you want to know which visit detail ID is associated with this particular record, you will need to join the visit occurrence ID with the visit occurrence table, and then joining with the visit detail table. Node source value is an scramble of the Epic Clarity identifier. And load table ID is the Epic Clarity table from which we are taking this particular clinical node. If we count the number of clinical nodes we have a staggering number of 121 million clinical nodes. This includes everything. This includes progress nodes, ED nodes, all the inpatient nodes, discharge summaries, history of physics. It even includes pathology reports, radiology reports, and also includes a lot of small and short communication. You, as an exercise, can explore the content of the node by running these two cells on our Nito Secure Computing platform. Now, if we want to check the metadata of a particular node, this cell is what it's doing is that we're going to select just randomly 3 nodes. We're going to check what these nodes are about, and we're going to select one of them, one of these node IDs. Then this randomly chosen node ID is joined with the visit occurrence table to get information regarding the visit, is joined with the provider table to get information about the provider that wrote the node. And in this case, we have that this is a clinical node that was written as part of an outpatient visit. It's called a procedure node. It's written by a nurse practitioner. And we have the name of the node practitioner and the date on which this node was written. Then we're going to explore a use case of a delivery procedure. And this is particularly interesting because in the clinical node, we may find things that are not even associated with the particular visit for this set of patients. And we're going to see whether we can even find information in the clinical node that is not in the structured data. First, what we do is to create a concept set that we're going to call delivery procedure concept set. The way we do it, you can remember from tutorial 2, we're going to use the concept ancestor table, and we're going to take this concept ID as the parent, that is just delivery procedure, to get all type of deliveries. You see here, if we inspect this concept set, there is even some maybe non-expected procedures, but they are considered delivery procedures. So we get all of them. And then we are going to find all the patients that have this delivery procedure. How do we do it? We query the procedure occurrence table and we say, give me all the procedure concept IDs that are in the set. And then we're going to just count the number of unique patients that have this particular concept. And as we see here, the number of unique patients for some of them are 14,000, 12,000, and so forth. Then what we're going to get is the list of actual patients that actually have this. Then same deal, where the procedure concept ID is within the concept set. And then we can actually check some of them. We are going to create a table that will save all the information related to those procedures with the person ID column, the visit occurrence ID, the procedure concept ID, and the procedure occurrence ID. Then we can check what are the procedures, all the procedures associated with those visits. Because by this way, what we're saying is that give me all the procedures that are actually within that visit. So we get all the visits associated with those procedures, and then we get all the procedures associated with those visits. And these are all the procedures. Some of them are actually fairly common procedures done during delivery. Then we're going to get also all the conditions. How do we do it? We're going to say, give me all the conditions associated with those visit occurrence IDs. And then we get all the information related to those visits. And if we see, these are the conditions. Some are fairly generic. Some are actually better related to what is happening in a single live birth. Then, as a bonus, we also have the possibility to check which are the drugs associated with those visits. And then, same deal, we're going to join by the visit occurrence ID and get all those drugs. And then, as you can see, they are usually drugs associated with delivery. Then it comes to the meat of this particular tutorial. Let's also get the notes. And how do we get it? Exactly the same, by joining with the visit occurrence IDs. And let's see how many nodes we have. We have a staggering number of 9 million nodes associated with those visit occurrences. Then here it comes the first capability that BigQuery as a backend offer to us to support research using these nodes. You have at your disposal full text search that you can do with these clinical nodes. And what is amazing is that this full text search is very fast. Here we are going to use just, let's say, one keyword. You can actually put more keywords there if you want. This one is blood because we want to find deliveries that may have an increased blood loss, maybe a hemorrhage. And then, but you can also get fancy and you can actually get a regular expression that may contain some variations or may even account for some lexical or spelling variations, so you get a wider coverage of which nodes are actually getting that. So with that, you can check these nodes tests if you run this on the Nero computing platform. But with that, we close the third part of our tutorial 4 and see you in the fourth.
The preceding program is copyrighted by the Board of Trustees of the Leland Stanford Junior University. Please visit us at med.stanford.edu.